Hello, welcome back to Economics channel. Hope I met you well. Of course, you met me well. So we'll be proceeding from where we stopped. I think last class. What did we even talk about? Anyway, this class we'll be looking at standard normal curves, right? Okay, I think we spoke about normal curves in the previous class. So today we'll be talking about standard normal curves. I'm going to say something now, and then I want to do it quickly before I continue with the class. So please go, and if you don't have the Z table, there's a table called the Z score table, like Z then score. Okay, the Z score table, or another name for it is the standard normal table. Please pause this video and download it. Download it first and then return to this video because we are going to be making reference to that table, right? So thank you very much. All right, the standard normal curve. So what's standard normal curve? So the standard normal curve is a curve that shows normal distribution with a mean of 0 and standard deviation of 1. Okay, that's it. Like it's the same thing as what we've been doing, like what we did in the first class on normal distribution. Just that here we kind of convert the normal distribution curve, right, into a standard normal curve. And that means we just kind of try to express the values on the normal distribution curves, right? Or, we had a mean, then I think we are looking at height of babies and of adults and something like that. So, like those values, the height of adults, I think 60 and 80, the mean was, we didn't even talk about the mean, did we? I don't remember. Okay, the mean was 70. Anyway, the mean was supposed to be 70. I'm not sure if we talked about the mean. Okay, exactly. But the mean was supposed to be 70, right? Because we had two scores like on the left hand at 60 and 80. The mean was 70. So now instead of having 70 on the normal curve, we then convert the 70, we express it in terms of the standard normal curve. So 70 becomes 0. There's a way to do that. 70 becomes 0, then other values are now expressed in terms of 1 to 3, something like that. Okay. The formula for converting a normal curve, okay, into a standardized normal curve is simply this. Where is it? The z-score. Okay, your z-score is equal to x, which is the value of one of the values of the variable. Okay, so let's say the examination scores of students. So one of the examination scores. Also x minus the population mean, then divided by the standard deviation. All right. So when we do that, we would be able to convert all of those scores that we have on the normal distribution into a standardized normal curve. Now it's not difficult. We are going to talk about that as we progress. So now I don't know if you've come across something like this before. X is normally distributed at you have, this is the mean, and then this is standard deviation like an R. Okay, in case you've seen something like this is just trying to tell you that X is the variable x is normally distributed. Why? The mean, which is this mu, is 0, and the standard deviation is 1. Okay, so on for the standardized normal curve, for you to know if a variable has normal distribution when you're using standardized normal curve, so your mean has to be 0 and then your standard deviation has to be 1. All right. So a standard normal curve is used to show a standard normal distribution with a mean value of 0 and a standard deviation of 1. And if you recall, I was saying that when we were looking at what we were even talking about, was it? Have we started talking about intervals? I was talking about standard deviation. I was talking about yeah, I think we're looking at yeah, there was a feature of the normal curve I was trying to tell you that I told you about in last class that there is for a normal distribution there is a 95% chance that um all most okay, let me, how do they even put it, most of the values of this distribution are within two standard deviations on either side of the mean. So 95%, okay, let me put it that way, 95% of the distribution of x variable x, right, are within plus or minus two standard deviation. Let's put it that way, plus or minus two standard deviation at least. Two standard deviation to the right, two standard deviation to the left, and then these tails they occupy 2.5% each, right? You remember that? Okay, so for which converts a normal distribution into a z-score to bring it into the form of a standard normal curve. Now, the mean here has become 0. Don't worry, we'll solve an example. The mean here, or two examples. The mean here has become 0. So this is A here. So this A is representing a value that is one standard deviation away from the mean. Then B is representing a value that is two standard deviation from the mean. F is representing a value that is, plus three standard deviation away from the mean. Same thing as C, D, Z, just that now C is representing values that are minus one standard deviation away from the mean, then D minus two standard deviation, whatever. So that's what we have here. So A is equal to 0 plus one standard deviation away from the mean. B is 0 plus two standard deviation away from the mean, which is 0. Then F, I didn't write it. So F is going to be, let me just, no, F is going to be 0 plus 3 standard deviation away from the mean. Then Z here, should I even use a Z because we have a Z score? Um, Let me use a Q. So Q is equal to the mean is 0 minus 3 standard deviation away from the mean. All right, like I said, you don't really have to bother yourself. So we'll walk around it and then you're going to understand it. Okay, but before we get into that, the area, under um the area under the normal distribution curve is equal to 100%. Okay, I can say the area is equal to 1. All right, the area is equal to 1. So everything, the area on all of this above the horizontal line and then beneath, what do you call it? Beneath the normal curve, everything like this, we give you 1, or let's say 100%. Okay, the area is 1. So now we want to begin to use our the table I said you should download, the standard normal table or the z-score table. So on it, you are going to see the values of z-score to the left. Okay, the values. So there are two different tables. One is you have this um, value of z-score to the left, value of z-score. Let me just put left to the left. So what does that mean? We're going to know. Then here you have like the decimal place, point 00 should I use that? Point 01, point 02, on and on until you get like point 0, point 0.09. And then if you're looking at the positive, so positive is starting from 0, 0 0.1, 0.2, whatever, 0.1, 0.2, 1.1, then up to 3.9. All right, up to 3.9. So the thing is that the lowest value for positive values of z-score, the lowest, the what you have here now represents area, right? The values of area, okay, corresponding to a particular z-score. The values of area, okay, that is corresponding to a particular z-score. So you have for your positive, because it's positive for positive values, the lowest of them is 0.5. Where is it? For 0 points, no, 0 points, you're starting from 0 0.0, 0 0.1. So here you have 0.5000, something like that. Now, when you do for negative values of z-score, um, how do you know? You just find that the numbers that you have here, they are in minus. Okay, negative values of z-score. So let me just do that. The negative values are, so this one is also up to 0.09. It should be 0.09, 0.00, 0.01, yeah, 0.09. So here you have minus 3.9, then minus 0.0. So for this, the highest number is 0.5. Where is it? So you're going to be having the 0.5. This is the lowest number for this. So the highest number for this is 0.5. And I want to be sure if that is where the 0.5 is supposed to be. Okay, 0.5, 1, 2, 3, 4. So same thing, it has 0.00, 0.01, 0.02, 0.03. All right, like I said, download it for you to be able to be sure of what we are trying to do. Okay, so now find the area under the standard normal curve that lies to the left of 1.23. So how do we use that? Okay, how do we use the standard normal curve to find that? So you have, what we are looking for is 1.2 under 0.03, because of course 1.23 is same as 1.2 plus 0.03. So this is going to give us 1.23. Alright, so we come here. So where do you have 1.2? I'm just going to put an arbitrary 1.2 here. So we are looking for the value at 1.2, then 0.03 here. So there's going to be a value where they are going to meet. So that is the value of our area corresponding to the z-score of 1.23. So like I said, all these values are to the left of the z-score. So that is, if we're to 1.23 is going to be like a value here. This is 1, right? So 1.23 is like a number here. So I can just put z, okay, equals 1.23. So area to the left is talking about this is this area to this side, right? Area to the left. So from this z equals 1.23, all of this area, what is the area of all of this thing? Up to the end of it. So it's excluding this part. And that's what this normal table is trying to give to you. So 1.2 under 0.03. So you'll be getting, you're telling me, right? I like that. I like that. I like that. So well, let me verify. Let me verify it here. So I think you'll be having 0.109, no, 0.8907. So we're having 0.8907. That is the area. So we have the number here is 0.8907. And then that answers the question. So the area under the standard normal curve that lies to the left of 1.23 is solution. So the area is 0.8907. That's all. Okay, then that's A. Then for B, so we are looking at the area that lies standard normal curve right of 0.76, right of 0.76. So now we are not, no, I don't know if I should. This one is just talking about all of this. All of this. Okay, so maybe I should just erase this guy, this little one. All right. So 0.76 is going to be, can be here. Yeah, it's more than 0, so we can have 0.76. Where is this? 0.76. So area to the right. So you are looking for area to the right of 0.76. But remember that the value of your z-score, they are to the left. They are giving areas to the left. As we already know that the area under, the standardized normal table, the area under the normal curve, right? Then the area under it and above, like all of this enclosed area, everything is equal to 1. So first we get the from our z-score, we get the area to the left, then 1 minus whatever, 1 minus that area then gives us the area to the right. Okay, so 0.76, let's just put an arbitrary, so we are looking at 0.7, right? 0.7, then under 0.0, under 0.06, so 0.7, 0.7 under 0.06. Alright, so check. Let's verify. So we're having 0.7764. Okay, 0.7764. So that's area to the left, okay, of the z-score of 1.23. So area to the right. So area to the right, so equals 1 minus the area to the left, 0.7764, and then that gives us 0.2, 0.2236. 2236. All right, then the last one that I want to do. So the last one is talking about negative z-score, a negative z-score. So a z-score of where is it? A z-score of 0.68, and then to the right, z-score of 0.68 to the right. So if this is the mean, okay, 0. So minus 0.68. So we are looking at minus 0.68, minus 0.68. So maybe something like this. All right. So we are looking at the area. All we are looking for is area to the right. All right. But then this guy just give us area to the left. So minus 0.6. We are looking at minus 0.6 under 0.08. I think it's given us just 0.08 anyway. So we are looking at this. So the number there is 0.2483. 0.2483. All right. So at the end of the day, the z-score, the area of the z-score to the right, is going to be let me just area of this one is z-score. Looks rough. Area of z-score to the right. So this one, so area of z-score to the right, so is equal to 1 minus 0.2483, and that's going to give us 0.7517. 0.7517. All right, so that's that about finding the area of a specific z-score. So there are three, I think there are three, they are going to like four different things, because this one I just talked about just looking at point estimate, area of this, area of that. So but we are going to be doing three other things, hopefully, if you have the time in this video. So the next time we are going to is finding the area between two z-scores. The area between two z-scores. Find the area between two specified z-scores. So we have this example here. Find the area between the z-scores of minus 0.68 and 1.82. So we are not going to be wasting our time here. So we have so we are looking at minus 0.68. The z-score here, minus 0.68, and then 1.82, 1.82, you know. So basically speaking, like this. Basically speaking, what we are trying to look for is the area between this space. That's what we're trying to look for, the area between, this space. Okay, to get that, okay, with the z-score of this, looking at your z-score table, so area of z equals minus 0.68, will give us 0.2483. Is that it? 0.2483 using your z table. 0.2483. You know what that means? So this area to the left, that is from this, so this black area to the left, that's all. Then area of 1.82, area corresponding to the z-score of 1.82 is going to give us 0.9656. 0.9656. So what this means, right, is that all of the area from 1.82 to the left. So in other words, we are having the first one, this is just measuring the area of this part, okay, and then the other one is measuring the area of this whole part. So of course that is why it has a bigger area, because it's covering a bigger extent. So this is covering all of this. What we are trying to do now, the area of 1.8 that is covering everything minus the area of this small part will give us the area in between will give us this area. This is exactly what we are looking for. Like this portion, exactly what we are looking for. So this is the area that we are looking for. So do you get it? The area of 1.82 is everything up to this point. The area of minus 0.68 is just this part. So this whole thing minus this small part will leave us with what is here. So that's how we get so the area, I call it change in area. Change in area equals 0. Okay, it's not going to contain it. So equals 0.9656 minus 0.2483, and that gives us 0.7173, 0.7173, and that's all. Right, that's all. So you're going to be having, you know, exercises on these things. You know, they are pretty much simple. All right. So the third part, I think, time is already not on our side. The third part is finding this course with known areas. So now you've known the areas, so you're trying to look for the corresponding. So yeah, we are under finding this course with known areas. So this is an area of just this part. This is the area of just this part. I don't think I drew them equally. They're supposed to be equal. Okay. At least look like they are equal. So they are equal anyway. All right. So of course, this is area to the left, right, of this particular z-score. So we are looking for a z-score that corresponds to this area. So this area is to the left of whatever z-score is here, and then this area is to the right of whatever z-score we have here. Now let's start with this. Recall this is 0.025, right? Recall that I told you that um, under positive z-scores, the lowest number there is 0.5. That's where we start from. And then you have 0.9997 or thereabout. So you can't find 0.025 when you're looking at positive z-scores because the lowest number there is 0.5. All right. So for this, we have to be looking for 0.025 under the negative z-scores. Negative z-scores. So the thing here is that instead of you try to apportion z-score and whatever, so in your so you're looking for my a negative z-score under minus, so minus 3.9 minus 0.0 something like that. Then you have 0.01 on and on to 0.09. So you begin to look at this area, begin to look at all of these parts. So where would you have 0.025? Where would we have 0.025? So to help you out, like you just have to keep looking at it and find the closest value, okay, to 0. If you know 0.005 exactly, so like what is the closest value to 0.0? What is the closest values of this area? So now the answer actually is minus 1.9 under zero point 0.06. That's actually where the answer is. And here we are lucky that we just have 0.02500 or something like that. All right, is it even 0.025 or 0.25 now? 1, 2, okay, 0.025. So 2, that's 2.5%. So this z here is on minus 1.9 and under 0.6. So z equals minus 1.96. Let me call this one z1. How about z2? Now for z2, look at it. This is to the right of z2, but under your what do you call it? Under your z-score table, the values you have there are to the left. So which means we are not even looking for 0.025 under positive figures, right? Because we won't even find it. Okay, of your z-score. What we are looking for here is what is the corresponding value of z2 to the left. Do you understand? And to get that, the first thing we have to do is 1 minus 0.025 will give us the corresponding value of c2 to the left. Okay, and this is going to give us 0.975. Yeah, that should be 0.975. Let me cross check so that we know. Yeah, 0.975. 0.975. So what you're now going to be looking for in that means all of this area, this part is 0.975. So if you look for 0.975 under your positive z scores. Okay, so By the time you begin to look for it, you're going to find it at 1.96. As you're going to find it at 1.96. So again, you're not looking for 0.05 because it's the value to the right. And the values on your z-score table, they are to the left. So 1 minus the total area is 1. 1 minus this will give you this, right? So this is what you begin to look for. And let me see if this is approximately 0.025. And I think it is. Okay, I think it is. So 1.96. So that's just it's 1.96. So I think that's how we roll when we are beginning to look for area of you know um when we begin to look for this course corresponding to a particular area. Now you might be wondering, why are we doing all of this? And these are building blocks, right? So that by the time we begin to enter some topics, you won't be wondering that wait, I don't understand this, I don't understand. So like just enjoy yourself. These are very, very simple things, right? Okay. So enjoy yourself all through. Then we'll continue to like add some more bricks to what we built, to our foundation, and you will realize that the whole thing is pretty simple to understand. So next thing that we have is our assignment. Yeah, so we have the assignment on the board. Find the area. So the assignment covers everything that we've done in this particular video. So find the area under a standard number curve that lies to the A left of 2.02, B left of 0.56, right of minus 3.7, and D right of 4.2. And number two, determine the area under the standard number curve that lies between minus 0.18 and 1.44, B 0.59 and 1.57, C 1.1 and 4.2, and D 1.2 and minus 1.5. So the last one says that under the standard normal curve, obtain the z-score that has an area of A 0.33 to the right and B 0.8 to the left. So in our next video, we'll be looking at the practical application of the z-scores in approaching probability problems, etc., etc. And I think there was one thing I didn't mention in this video is the fact that you might have two z-scores corresponding to a particular area. For example, let's say you were looking for the area of 0.5, and then a z-score gives you a value of 0.498 something something, maybe 0.499 and thereabout, and then the other one gives you like 0.501, um maybe something like maybe 0.501 something like that. So in that case, what you have to do is you add up the z-scores and divide it by 2. Okay, so where you have two areas that are very close to each other, and neither of them gives you the specific area of the z-score that you're looking for. So you just add up the two z-scores that gave you those very close values and divide by 2. All right, so there was a problem like that, but I didn't solve it in this particular video. But just to call it to your attention.